Alright, going to look at fractions today. I'm actually recording this after part 6, but it shouldn't matter, the content's still the same. These confuse a lot of people, but they're not too difficult to understand. So I'm going to go through the basics first. The numerator is what we call the number on the top of a fraction, and the denominator is what we call the number on the bottom of a fraction. The numerator is the number of parts you have, and the denominator is the total number of parts. So we're back to the pizza again. I want you to imagine that you work for Domino's or Pizza Hut, and this is one whole pizza, fresh out of the oven. So we write one whole, just like this. Then it gets picked up by a paddle and then stuck in a box, and the team then takes a big blade and starts slicing the pizza. So we can slice it in half, and you will have two parts, 1 and 2. If we cut it again, we'll get 4 out of 4 parts. If we cut it again, like this, and then like this, we will have 8 parts out of 8. But it's still one whole pizza, no matter how many times you slice it. For the fraction 3/8, the 3 is the number of parts you're going to eat. So this would be part 1, part 2, part 3, and then you would have 5 parts remaining out of a total of 8. I think that's the really easiest way of explaining it. Again, we've gone for pepperoni pizza rather than Hawaiian for obvious reasons. So yeah, next we want to look at equivalent fractions. I think I've covered it a little bit there on the previous slide, but if you've got one whole pizza, the way you slice it determines how equivalent you've got. So if you slice it in half, you've got 2 halves. If you slice it again, you've got quarters. If you slice it slightly differently this time, I'm going to delete that. Let us slice it this way. We have sixths, and let's try and do tenths. So I'm going to need 5 lines here. 1, 'It's not perfect, but then they never are when they come out of the box from the pizza shop. So obviously, if you're going to eat 1/2, you'd be eating this. If you're going to eat 2/4, you'll be eating this. 5/10, you're eating this. and 3/6. You're eating this. So again, it comes down to the way you slice it. These are not equivalent fractions, so I've split the pizza into thirds with these cuts and into quarters with these cuts. So these will not be equal. And you can't very easily add a third to a quarter either. You get an odd amount, but it is possible to work out how many you're going to get. I'll come to that in a minute. But yes, you need to know that the way you cut it, some of them will not be the same. So here we go. If I wanted to add that third to a quarter, how many am I going to get? How much pizza am I going to get? Well, we cannot add a third to a quarter. You will not do this. That does not work. Just doesn't. Sorry to say. You can't very easily add those two fractions together as they are. But if I go back to my pen and back to the previous slide, I can split these slices up into smaller slices. Same goes for this one as well. Okay. Come back to the sum now. So we need to create smaller slices. How do we do that? Well, we need to look for what's known as the LCD, or lowest common denominator. In fact, I'm going to type that in because it makes sense to do it. And it's very simple to get the LCD. You take the two denominators that you have and you multiply them together. 3 times 4 gives you 12. So we are looking for twelfths plus twelfths equals. And this is where I change pen. We'll go for a nice purple. So how many times bigger is 12 from 3? Well, I've had to multiply 3 up by 4 to get 12, and I need to multiply this up by 4. Gives me 4 over 12. Next, I look at the 4. What have I done to that 4 to get to 12? I've times by 3. So if I times the numerator by 3, I will get 3. And finally, we can finish the sum now because the denominator is the same. We can add those slices together. Gives me 3 plus 4 over 12, 7/12. So you can only add the numerators together if the denominators are the same. Same works for subtraction. You need an LCD. So again, 6 times 5, 30. So I want over 30 minus over 30. What am I doing to this 6? Well, I'm timesing it by 5 to get to 30. Means that I've got to times this 5 by 5 to get to 25. And then if I swap out to a nice blue, whoop, times by 6 here to get to 30, times by 6 here. 2 6s are 12. 25 minus 12 is 13 over 30. Simple. Multiplication is next. So you'll be pleased to know that this is very simple. You do not need a lowest common denominator to multiply fractions. All you have to do is 3 times 6 and then 4 times 10. 3 6s are 18, 4 10s are 40. But unfortunately we cannot leave it like that. We have to go down to the simplest fraction possible. So we say, what can I do to that 18 to make it smaller? I can divide it by 2, or say that the times tables to make 18 is 2 times 9, and 40 is 2 times 20, giving me an answer of 9 over 20, because the 2's cancel out. Really simple. And you have to go down as low as you can possibly go. It won't go down any further because we should know that 9 is 3 times 3 and 20 is 4 times 5. There's nothing there that will cancel top and bottom, so that is your final answer. Division. Swig of coffee. There's a trick to division. The trick is called KCF, which stands for keep, change, flip. So what we're going to do is we are going to keep the first fraction. We are going to change the symbol. And we are going to flip the final fraction. So what I'm going to get is 5 over 8. That's the one we keep. We change the sign to multiply, and we flip this so it's 7 over 6. And this just becomes a bog standard multiplication. 5 times 7 over 8 times 6. 5 7s, 35. 8 6s are 48. And I don't think that cancels down because no, that's as low as it will go. 35 over 48. Cancelling down fractions, you should be aware of this. Again, you do this using your times tables, so we should know 48 is 6 times 8, and 72 is 8 times 9. That's going to give me 6 over 9, because the 2 8s cancel. And then 6 is 2 times 3. And 9 is 3 times 3. Answer is 2/3. You need to be able to do that. Remember the pizzas. We're going to look at mixed fractions now. What does 3 and 1/4 mean? Well, the quarter is just like the numerator and the denominator that I'd told you about previously at the start. And the number at the front are the wholes that you have. So we've got 3 whole pizzas. 1, 2, 3. And then if I split the 4th pizza into quarters, yeah, we're not needing you've got that extra quarter there to generate that 3 1/4. Sorry about the messy graffiti. Kind of reminds me of Chris Pratt's face on the bus. There we go. That's mixed fractions. Top heavy fractions are ones where the number on the top is bigger than the denominator, hence being top heavy. Another way of describing these are improper fractions. How do we convert between the two? So, if we need to go from a mixed fraction to a top heavy fraction, we multiply the 5 and the 9 together, which gives 45, and then we add 8, and we divide by the number on the bottom, which is 9. (45 plus 8 is 53 over 9. Done. What about going back from a top heavy fraction to a mixed? Well, what does this mean? This means 72 divided by 10. If we do that over here, ten doesn't go into 7, but it does go into 72, 7 times. And then there is a remainder of 2. So I can say that 7 is the big whole number. 2 as the remainder is your numerator, and your denominator will be the same as you started with. That's it. So given that, you should be able to do something a little bit more complicated here. How are we going to go about this? Well, first we're going to need to convert to top heavy. So looking at 3 1/4, 3 4s are 12, plus 1, 13, over 4. Divide stays the same. And then we're going to look at this one. 4 5s, 20, plus 2, 22, over 5. Now that we have them as top heavy, we need to do our keep, change, flip. (13 over 4) is kept. Change times and flip 5 over 22. 13 times 5 is 65. 4 22s, 88. It's a bit of a messy 8. Can that cancel down? Nope. I think that's as low as it will go. But I'll be a bit naughty and check on my calculator. Yep, that is as low as it goes. It gives you a horrible recurring decimal there. Yep. Cool. That's it for the basics of fractions. On the next video we look at fractions of amounts. But there's some questions and stuff attached to this video for you to have a go at and practice. And good luck with it. See you soon.